Hello, and welcome to Class 15 on Cognitive Bias and Generalizations. In this section, we've been looking at how to reason with generalizations, and our focus has been on what it looks like when you reason correctly. We looked at two argument schemes involving generalization, inductive generalization, and instantiation syllogism. We also analyzed a more sophisticated concept relating to reasoning with generalizations, correlation. Now we are going to turn to psychological factors that keep us from making generalizations properly. So far, our sections on cognitive bias have looked at specific mental systems. So we looked at biases in perception in Class 7, and in biases in memory in Class 8. This time, the cognitive biases we're looking at aren't confined to a single system, but they do all impact our ability to reason with generalizations. Most of them specifically cause problems with inductive generalization, and so I'm going to be reviewing that argument scheme in this video. Okay, start with though, I'm actually going to review the basic terms around cognitive bias. In Class 3, when we first started talking about the psychological approach to critical thinking, we introduced two such terms, both of which came out of the research of Kahneman and Tversky. And now I'm going to turn you over to an earlier video where I talk about these terms. The terms are heuristic and cognitive bias. And these are related terms, but they aren't exactly the same. And often in the literature, actually, these terms are used interchangeably or sort of randomly, and sometimes people even throw in fallacies in this conversation. The use of the terminology isn't always that consistent. I'm going to impose a little bit of consistency on it because I think it helps you understand the evolution of this field. So when the field began with the work of Kahneman and Tversky in the 1970s, and when they first started studying the ways in which people are irrational, and the patterns in people's irrationality, they focused on what they called heuristics. Heuristics for them were shortcut methods of drawing inferences that work most of the time, but can lead to systematic mistakes in some contexts, right? So the idea is that all the biases we're dealing with are the result of cognitive shortcuts. Since that time, the use of the term has really expanded, and the term cognitive bias winds up being applied to basically anything that a psychologist can measure that's irrational. So I just to talk about the evolution of the field, I want to say that a cognitive bias is a broader term that applies to any widespread distortion in the way people think. And often you can't really cash these out in terms of mental shortcuts or heuristics. So, for instance, the hostile media effect is sometimes referred to as a cognitive bias, but it's not a heuristic. The hostile media effect is just the fact that when people think that the media is biased, they always believe it's biased against them, no matter who they are and what they think, right? And part of this is just because, if the media is agreeing with you, you don't say it's biased. You don't say it's biased in my favor. You just say it's reporting the truth. So this is a feature of the way we talk, and the way we think, but it's not a heuristic. But it is still an interesting bias. Um, Lurking in the background for all of this is going to be the idea that any cognitive bias that we have that's systematic serves some purpose, right? Sometimes people will emphasize evolutionary purposes. Our brains were evolved this way because it worked um, back on the veldt in Africa. Um, but often those are kind of vague stories. Um, the idea of a heuristic does easily explain why some cognitive biases are there. Um, Still, the lesson I want you to take away from is that a cognitive bias is a broad term, and a heuristic is a specific kind of cognitive bias that was the original focus of study. All right, so um, in this section, I'm going to start by talking about um, essentially the way you should be reasoning about generalizations. And then we'll talk about the biases that come up, which are all about the way you actually reason about generalizations. So thinking requires us to make generalizations. We're always making generalizations. I just made one right now. You have to generalize in order to think abstractly. But of course, as we all know, making bad generalizations can get you in a lot of trouble. Um, so, and in some ways, people often, when they think about racism. It's sometimes it's a complicated phenomenon, but sometimes it gets the first thing people think of is, in fact, people making generalizations about other races or ethnic groups, and that's definitely a part of it. So, in any case, being able to reason well with generalizations is important. So, I want to review what we learned in the last chapter about inductive generalization, right? Inductive generalization is just reasoning when you move from a sample to a larger population. You know something about a smaller group and you infer something about a larger group. So it turns out that the right way to reason with generalizations is given to us by statistics. Statistics becomes the science of accurate, um, strong generalizing arguments. So we want these technical terms, right? A population is just a group of things with a property. That's the way people talk in statistics. And when you make an inductive generalization, a statement about this larger group of things is in the conclusion, right? The conclusion contains a statement about the population. A sample is just a subgroup of the population. And when you make an inductive generalization, your premise is going to be a claim about the sample. So with inductive generalizations, our premises are about the sample, our conclusion is about the population. We're making an inference from a smaller group to a larger group. That means that this is inductive. Inductive is a very important term here. It means that you are taking a risk when you make the inference. You could quite easily be wrong because your conclusion contains more information than is in the premises, right? Um, this is in contrast to deductive reasoning, where you can be certain of your conclusion because actually it's just rearranging the information that's already in the premises. So, inductive generalization, it's fallible, but when done right, you can have strong and cogent arguments. So, our basic scheme for inductive generalization is just we have a premise about the sample. In the sample, X% of F's are G, and the conclusion in the whole population, X% of F's are G. When we're dealing with inductive generalization, we need to ask two questions. These are the critical questions that we use to evaluate inductive generalizations. Is the sample large enough? And is the sample representative? And when we talk about a representative sample, what we are looking for is a random sample, which is defined as a sample in which each member of the population has an equal chance of being in the sample. So this is what we really want to be doing. If we're reasoning well and we're making generalizations, we want to be doing it with at least statistical levels of precision. But of course, we're not. Statistical science surveys are group efforts. Like all good science, well, almost all good science, I guess, it's a collective process. Science isn't the work of one isolated individual working in a lab alone. It is a collective process of people checking each other's work, replicating experiments, confirming things. Um, Honestly, an individual just doesn't have the resources to reach the level of accuracy that statistical arguments get. So we're stuck making mistakes, and the mistakes we make follow certain patterns. So in the remaining sections, we'll just talk about those patterns. So the first pattern of mistakes I want to talk about is comes under the heading of the availability heuristic. And we're actually going to spend a fair amount of time on this one compared to the others because it's a big catch-all category that captures a lot of different kinds of mistakes. Um, and these are actually the ones that I think are most relevant, come up with inductive generalization. So the availability heuristic is defined simply as a form of cognitive bias when that occurs when one only looks at the examples most readily available. And so, if this were statistics, we would call this a kind of sampling bias. If you're conducting a scientific survey, right? And your sample, and you don't have a good sample, we say it has sampling bias in people's ordinary experience, well, there's also a kind of sampling bias, but it's everywhere, and we just call it the availability heuristic. A lot of this comes down to our inclination to think that things that are easier to remember are more likely to occur. We don't actually make that connection consciously. It's just that there are things that are easy to remember. They affect our thinking more than they actually happen, right? So the text has a few examples of these. I'm just going to run through them in the class. I think pretty quickly you get you get how these start to work, and then you realize um, that you just want to use the less intuitive answer. But here, let's just do a few, and I'll explain. So, question: are there more English words that begin with the letter R, or that have the letter R as their third letter? Just think about this. Write the answer down on a piece of scrap paper. Well, a lot of times people, when they're just thinking on their own, say, gosh, I can think of a lot of words that start with the letter R. Rain, rainbow, Rambo, I don't know, but lots of words. Ram, room, Roomba, roofer, roofie, all of these, right? And so you think, oh, it's probably that there are more that begin with R, but it's not true, right? Um, Uh, so many of us think, at least when we aren't primed to think there's a trick involved, that more words begin with R, although this is false. This is just a quote from the text. Um, and of course, that's the other thing, right? You know that there's going to be a trick involved with all of these because there are questions in a video about cognitive bias. So you might think, oh, I can think of a lot of words that start with R, so I bet that's not the answer. And it's going to go on like that. Still, there's some more examples like this that I want to emphasize. Which is a more common cause of death for Americans, terrorism or car crashes? I think this one's pretty easy. I mean, you know where this is going. Obviously, um, car crashes are actually more common than terrorism, although people tend to worry more about terrorism. The actual numbers I thought were significant enough that I wanted to include them. Um, Around 12 in 10,000 people are killed yearly in automobile accidents. So, I mean, that's going to touch someone you know. And, it touches people in my family. It's a common thing. whereas only 1 in 30 million Americans are killed by terrorists in a year. Um, of course, you hear more about them because terrorist attacks strike fear. That's how they're designed, right? Okay. Um, and I have the same slide in here twice. So the thing that I like actually about this reading is the text has some advantages and disadvantages. I've noticed in this section in particular there are a lot of editing errors, which is kind of embarrassing, but that's what happens when you work in for free. You're just giving your product away. But one of the things I like is that they have a good discussion of why misleading information tends to be more available than the correct information, and hence the origin of the availability heuristic and the problems with it, right? So media coverage is biased. Surprising events are memorable. Events close to home are memorable, and our everyday sample is biased. Everyday samples are biased. I want to cover each of these in turn. Um, Media coverage being biased is obviously well known. Um, but I think people don't always appreciate the way that media coverage is biased, or if they do, they just think it's biased against them personally. Um, so let's do a quick trivia question. Is the crime rate higher or lower nationwide than it was 30 years ago? Go ahead. Write down an answer. Think about it. Is it higher or lower? Well, most Americans say it's higher. And so my source here is the Marshall Project. I've got the link in the slides. Um, in fact, right now, 56% of Americans believe that crime is up in their neighborhood, and 80% believe it went up um, nationwide. But it's not true. Crime rate's lower. There was a big peak in crime, all categories of crime, in the early 1990s, and it's been basically declining since then. Um, so there are a lot of reasons why people overestimate the crime rate. And the obvious one is just that media coverage is biased towards violent crime. If it bleeds, it leads, right? I mean, the media love to cover violence. There's some other things going on with this effect, though, that I want to dig into. Um, so, one thing is that uh, people, when you ask them to reason with numbers, generally take lots of shortcuts, right? So, here's a question for you. When I asked you whether the crime rate was higher nationwide than it was 30 years ago. Did you actually think specifically back to the 90s? Did you say, ooh, yeah, okay, 30 years ago, that would have been 1993. What was going on in 93? Um, I bet a lot of you didn't. I think what's more common is people just think, oh, well, back in the day, sort of vaguely back in the day, things were safer. Um, Another important thing about crime is to remember is that crime statistics are very easy to manipulate. And there are a lot of people out there with an interest in manipulating them. Just for starters, crime rates fluctuate a lot. And this means that you can make crime appear to be rising or falling just by changing the time horizon that you're considering. So this study used 30 years. Um, if you use a shorter time horizon, you can capture, um, you can make it look like it's going up overall. And some of this is because there was a spike specifically in the murder rate as a result of the pandemic. And the reasons for this are complicated. But if you focus on a narrower band of time, you can always cherry pick a band of time that gets the result you want. Different types of crime fluctuate differently. Um, so you can focus on specific crimes that grab people's imagination and are trending the way you want them to. So if you want these days to make people worry about crime, you can focus on the murder rate and just look at the period of time since 2020. Um, this is, I mean, this is a way you can create fear. Another important thing is that crime rates are driven by super local factors, but they tend to be blamed on national policy. Um, and so the party that controls the White House winds up being blamed for changes in individual cities and neighborhoods, which are, again, are the crime rate is actually driven by local factors here. And this gets to a feature of why people manipulate crime statistics. People have an interest in manipulating crime statistics. If you want to run for office on a tough on crime platform, you want to make people afraid of crime. Um, Police unions have an interest in promoting the idea that crime is going up, and that is because it increases their budgets and it increases their profiles at a time in which they might otherwise be under criticism for violence against unarmed black men, for instance. Um, Also, stores tend to want to emphasize property crimes like shoplifting. Um, and, they do this so that they can blame their own poor performance on something other than their own bad decisions, right? Um, so crime statistics are easy to manipulate. You should always take them with a grain of salt. Try and look for a bigger picture. But this just gets back to the general um, feature that the availability heuristic combines with media bias to make us think that things are true when they're not, right? Um, Another important aspect of the availability heuristic, and a particularly nasty one, is that surprising events are memorable. Something weird happens, it stands out. But by their very nature, surprising events are rare. And rare events make for bad generalizations. So, in this case, the availability heuristic, the fact that something is memorable, actually leads us in the exact wrong direction. We remember unusual things, and that makes us think that unusual things are usual. They're not. This particularly has a disastrous effect when judging medical treatment, and the discussion of this in Southworth and Sawyer is worth quoting it in full. In all but the most extreme conditions, almost any miracle cure or quick fix for losing weight, kicking cigarettes, quitting gambling will seem to work for some people, perhaps because of a placebo effect, perhaps because of sheer coincidence. In such cases, we may hear an endorsement, perhaps in an infomercial, from people who sincerely believe that they have benefited from the treatment. Such testimony might be compelling. It's often easily available in memory. In such cases, the availability heuristic tends to make us spend a lot of money on quick fixes that don't fix anything at all. Think of it this way. You've got sugar pills, you want to claim that they cure cancer. You give them to a bunch of people, um, and one of them has cancer that goes into remission, just because cancer goes into remission sometimes. You then put that person on TV and say, my miracle cure cures cancer. People remember that. That sells. People remember personal stories far more than they remember statistics. This is just a feature of the human thinking that we have to cope with, right? If you want to convince someone of something, don't give them numbers, tell them a story. Of course, if your story goes against what the numbers actually say, you're lying, you're misleading at the very least, right? You're being deceptive, and that's wrong. So we have to, when we're communicating, both understand the power of stories and recognize that stories provide more evidence, convince people more than they actually provide evidence for the truth. And this comes up particularly in statistical situations and particularly in medicine. All right. Another thing that happens is that cases close to home are especially compelling. This happens if something happens to one of your friends or your family members, you are deeply, deeply inclined to believe that that is the norm, right? So the example that the textbook gives is your Aunt Ethel has a Toyota Prius. It's a real piece of junk. And you're going to trust that experience over a reliable statistical survey that says that Priuses are more reliable. In fact, if you don't, it will even seem like a betrayal. What, you don't think I trust my Aunt Ethel that these cars suck? Um, so again, um, we need to be aware of the biases in our thinking, and whenever possible, hew to things that are actually scientifically reliable. In general, our everyday experience is biased. We tend to focus people of our hang out with people who are our own age, um, who are our own race. We know people from our jobs. We know people from our geographic location. Um, and this means that we have a deeply biased sample of what's going on with your ordinary person. One thing I've noticed in just teaching at community college is people have radically different ideas about how computer literate you should expect someone to be. Someone who works with computers all day long is also surrounded by people who use computers all day long, also use computers all day long. They communicate with them mostly through their computers. And so you become unaware of the digital divide, the people who are not terminally online. And you make assumptions about what they know or about what they know how to do with computers that just aren't warranted. That's just one example. Um, the main point is that our everyday samples are biased. Everything that pops into our immediate mind, everything that pops immediately into our mind, um, is going to be misleading. It's not representative in a statistical sense at all. Okay, so I started out by saying that we need to use statistical, the good form of inductive generalization, which is basically statistical when we are making generalizations. And then I said, well, we're not actually generally following statistical rules. First mistake we make is the availability heuristic. We use the information that is most available, not what is the most statistically sound. The second thing to worry about is the anchoring effect. We've talked about this already. It is defined as um, a cognitive bias that occurs when the first piece of information affects judgment about subsequent information. Um, so, uh, right, this is in some ways a form of the availability heuristic. Because the first piece of information you get is going to be more available than the later ones. So this is a subset of that, but it's worth calling out in particular because it really is ambiguous. It really is ubiquitous. So I mean, this is a phenomenon that occurs all over the place. Occurs in solving math problems. That was how Kahneman and Tversky originally measured it, by giving people math problems and then not giving them enough time to solve them. Um, it occurs in asking your mother for a cookie. So this was the example that I gave last time from this Calvin and Hobbes cartoon, right? Mom, can I set fire to my bed mattress? No, Calvin. Can I ride my tricycle off the roof? No, Calvin. Then can I have a cookie? No, Calvin. She's on to me, right? Calvin is trying to use the anchoring effect here. Um, but there are all sorts of other situations that involve this: contract negotiations, first dates, job interviews. Um, You are making first impressions constantly. You are receiving first impressions constantly. These will always serve as an anchor that will bias later judgments. Calvin actually uses this a lot. Here's another cartoon from the Calvin and Hobbes fam. Um, right here, where he's also manipulating the anchoring effect. What he's doing here is setting expectations about himself and setting them low. So, why look, says Mom, you made your bed without even being asked to. That's wonderful, Calvin. Um, and Hobbes is there just as a stuffed animal because Mom is there. Mom goes away. Hobbes comes to life. Um, Gee, your mom sure is nice when you help her. Yeah, that's the reason I usually don't, says Calvin. I like Mom to be impressed when I fulfill the least of my obligations. So Calvin starts out setting his mother's expectations of him low, anchoring effect. All right, so if you haven't already done the exercises, you should do the first three. And in the in-person class, we paused here to do them. Um, there are two other mistakes, patterns of irrationality that I want to talk about. One is the base rate fallacy. Base rate sounds like a technical term, but it's really pretty simple. It's just how often things occur in a general population. So if 1 out of every 1,200 people are bankers, then the base rate for bankers is 1/1,200, right? So it's just like the overall rate of something in a population, the overall number of left-handed people, right? That sort of thing. The base rate fallacy occurs when we neglect base rates when forming judgments. And there's a specific situation where this comes up a lot that was originally studied by Kahneman and Tversky that I want to emphasize. This is called the representativeness heuristic. The representative heuristic is just the inference from thinking that something is typical of a category to the belief that something actually belongs to that category. If it looks like a duck and it walks like a duck and it quacks like a duck, it must be a duck. This looks like a completely reasonable inference. This looks like a typical X, therefore it is a typical X. And this really is a perfectly good inference most of the time. That's why we're calling it a heuristic. It is a perfectly legitimate shortcut. However, representativeness can make us forget base rates. And that's important, right? So here's the example that they give. Mike is 6'2", weighs over 200 pounds, most of it muscle, lettered in 2 sports in college, and is highly aggressive. Which is more likely? Is he a pro football player or does he work in a bank? Now, all the information I gave you about him makes him seem like a pro football player. But remember base rates. Very few people play for the NFL. Lots of people work for banks. So set aside the misleading information at the front and remember base rates. This is, again, something that Kahneman and Tversky discussed. Their example was very similar. It was a woman who majored in women's studies in college and there are all these things that make it look like she might be a professional activist. And then they ask, is she a professional activist or a banker? And in fact, many more people are bankers than work in banks than are professional activists. All right, the last thing I want to look at is the dilution effect. This is the one I'm spending the least amount of time on, but in some ways it's important, most important, because it comes up a lot right now. The dilution effect is the tendency for irrelevant information to weaken the strength of relevant information. This is an incredibly important disinformation technique. If you want to confuse people, make them unsure of what to believe, and therefore prevent them from taking an action that might be good for them, but you don't want them to do for whatever reason, you surround the good information with bad information. So one example actually about this comes up with vaccinations. Uh, the RFK Jr., the anti-vax activist, uses this a lot. You surround accurate vaccine information with bad vaccine information. You leave people confused. They don't know what to do. They don't get vaccinated. This was also a tactic used by Trump and his allies. This is Steve Bannon. People don't always know who he is. He was Trump's first campaign manager. Um, and he's in general a major strategist for the far right. In 2016, he engineered the Cambridge Electronica, Cambridge Analytica um, campaign. Cambridge Analytica was a firm that used Facebook data to identify people who could be radicalized, turned into right-wing extremists, white supremacists, that sort of thing, and then used to benefit the Trump campaign. So this is what he told the journalist Michael Lewis. Democrats don't matter. The real opposition is the media, and the way to deal with the media is to flood the zone with shit. If you follow Steve Bannon's political tactics, you realize that flooding the zone with shit is exactly his specialty. Forgive my language, but I think if the president's campaign advisor can use it, I can use it too. And it certainly accurately describes what's going on. There, we are being overwhelmed. We're being flooded with bullshit. And the presence of that bad information actually weakens our confidence in the good information that is out there. That is the dilution effect. Um, Later on, I want to have a class where we talk about bullshit and the uses of bullshit. I think one of the things as critical thinkers we need to do actually is not just understand good arguments, but understand the ways of bullshit and the ways that bullshit can be used to pull people away from good belief formation and manipulate them. All right, so that's all I've got for this class. You need to do the exercises. Talk to you later.